So this comes from Chapter 11, Converting Dosage Rates to an IV Flow Rate. So given the label here provided, the order reads 1 gram over 30 minutes. So there's three things to this question. We're going to find the dosage in grams per hour. Then it asks us to change the dosage rates to flow rate in milliliters per hour. And then finally change that flow rate to drops per minute if given the drop factor is 10 drops per milliliter. So we've actually done all of these components individually. The first one, finding the dose in grams per hour, we actually did, which was the dosage rate, which was done for test 2. So it's just more of a refresh now. And changing the dose rate, or the flow rate in milliliters per hour, and then converting it to drops per minute, we've done extensively in Chapter 10. You might be asking, well, why are we doing this? Why wouldn't we just stick to the IV flow rates? Well, you might have to. Not all medication is going to be readily available in an IV bag. So you might have to actually create the solution yourself, and it might be given to you in a solid form, shown here, 1 gram essentially. So you're given these orders from a doctor. The machine with IV will only register a flow rate of milliliters per hour, or even a flow rate in drops per minute, and you need to convert those. So that's why we're looking at a question like this. So the first thing says to find the dosage in grams per hour. So we have as our first fraction here, the dosage is given to us, always dosage is your weight of the drug over the amount of time it takes. Minutes or hours. Typically hours is the what we're going to use. So when we look at our dosage, we're given a weight of 1 gram, and our time for minutes is given, so we have 30 minutes. However, the question is not asking for grams per minute. If it was, we would be done, but we're not. It's asking for hours. So we need to take that 1 gram over 30 minutes, and we're going to multiply it by that unit fraction of 1 hour is equal to 60 minutes. So the 60 minutes goes at the top so that our minutes cancel out, and that hour goes at the bottom. So those do in fact cancel out. 1 gram multiplied by 60 is 60 grams. 30 multiplied by 1 hour gives you 30 hours. And then when we divide the two, we get 2 grams per hour. And that is part A. That's finding the dosage rate in grams per hour. So the dosage rate is 2 grams per hour. Now, you might also be asking, well, why are we even bothering calculating it in hours when it's given in, it only needs to go for 30 minutes? That's a great question. But in terms of the machinery you're going to be using, most machines won't program per minute or by minutes, it's per hour. So even though you're not infusing 2 grams, you're only infusing 1 gram and it will only last 30 minutes, you still might have to convert it to hours if that machine is only programmable in hours. Remember, the machine does a lot for us, but you still are the brains working that machine. So now we move on to part B. So we know our dosage rate is 2 grams per hour, but now we need to convert that to flow rate in milliliters per hour. So we're going to use the 2 grams per hour, but what are we going to multiply it by? We're not entirely sure. So the label is present for you. Unfortunately, it's not on this slide, but looking at it, this actual example, if you're looking at the book, is on page 300, example 11.2, and that label is there as well if you didn't want to flip back to the other slide. So we also on that label are given the strength of the medication. And we've actually done this for test 2, identifying that type of unit fraction. So it actually tells us the equivalency of grams in milliliters because the drug is actually given in milliliters. So 1 gram is actually equal to 50 milliliters. It tells you the injection, USP 1 gram, and at the bottom in red it says 50 milliliters. But also on the right, in writing, it tells you that each 50 milliliters contains 1 gram. So that's the manufacturer's guarantee that yes, for every 50 milliliters, you are giving 1 gram of medication. So because we're interested in milliliters per hour here, we want the hours to stick around in our 2 gram per 1 hour unit. So we need to get rid of the grams. So we're going to use the strength as a unit fraction, but the grams are going to be on the bottom and the 50 milliliters is going to be on the top, because again, we want the milliliters to stick around and we want the hours to stick around. The flow rate is not asking for grams, so we want to get rid of that. So 2 multiplied by 50 milliliters gives you 100 milliliters, and then 1 hour multiplied by 1 gives you 1 hour. So our flow rate is actually 100 milliliters per hour. So now for part C, it says change the flow rate from milliliters per hour to drops per minute if the drop factor is 10 drops per milliliter. And we have done this again. So we're going to use this unit fraction of the flow rate, but we're going to use the drop factor of 10 drops per milliliter. So now we're interested in changing our flow rate to drops per minute. So we're not interested in milliliters. So we're going to multiply the 10 milliliters by 1 hour by 10 drops over 1 milliliter so that those milliliters cancel out, which will give you 1,000 drops over 1 hour. However, the question is not asking for hours, it's asking for minutes. So we will need to use our unit fraction of 1 hour is equal to 60 minutes to get it into minutes. So the 1 hour goes on the top and the 60 minutes goes below, because again, we're interested in the hours canceling out. So we have 1,000 drops over 60 minutes, and if we divide that, we get 16.666667, and if we're going to round to a tenth of a decimal place, it'll be 16.7 drops per minute is that final answer for part C.